In this video, we're going to learn how to write polynomial functions given the zeros. And at the top of the screen, we have this reminder that says complex and irrational roots always come in pairs. So what I want to mention first is that roots and zeros are the same thing, so those words are pretty much interchangeable. So if you hear me using zeros or roots, just know that I'm referring to the same thing. And this reminder isn't going to be used in this first example, so we're going to ignore it for now, and I'll explain what it means once we get to an example where we actually have to use it. So for example 1, we're given these 4 zeros of a polynomial. So we're given the zeros 4, 2, -3, and 3. So what we need to remember is how zeros relate to factors, because we're going to write our polynomial in factored form first based on the zeros, and then we'll multiply it out into standard form. So over here, I'm going to write factors. So if our zero, one of our zeros is 4, the factor that goes with that is going to be x minus 4. So to go from a 0 to a factor, you're going to do x minus that 0. So if our 0 is positive 2, our factor is going to be x minus 2. If one of our zeros is -3, our factor will be x plus 3, because when you subtract a -3, it turns into positive 3. And if our 0 is positive 3, our factor is going to be x minus 3. So now if we want to write our polynomial, we're going to say f of x is equal to all of these factors multiplied together. So we're going to do x minus 4 times x minus 2 times x plus 3 times x minus 3. And now we want to just multiply all these out. So what I'm going to do is multiply these left two first. I'm going to FOIL. So I'll have f of x equals, and I'm going to keep my answer in parentheses so that I can multiply it by these next two binomials multiplied together after. So we're going to do x times x, which is x squared. X times -2 is -2x. -4 times x is -4x. -4 times -2 is positive 8. And then we're going to multiply x plus 3 times x minus 3. We're going to FOIL. We're going to get x squared minus 3x plus 3x minus 9. And now we're just going to simplify. So we're going to combine -2x and -4x. We're going to get x squared minus 6x plus 8. And the -3x and positive 3x are going to cancel out in the right set of parentheses. So we're going to be left with x squared minus 9. And now we have to multiply this trinomial by this binomial. So I'm going to rewrite it with the binomial first because I think it's easier to multiply that way. You don't have to, but I think it makes the problem a little bit easier. So now what we're going to do is not quite FOIL, but we're going to distribute this x squared into the second set of parentheses and distribute the -9 in. So if we distribute the x squared times x squared gives us x to the 4th. X squared times -6x gives us -6x cubed. X squared times 8 is positive 8x squared. Now we're going to distribute the -9. -9 times x squared is -9x squared. -9 times -6x is positive 54x. -9 times positive 8 is -72. And now we just want to combine like terms. We only have one x to the 4th term. And we only have one x cubed term. So we have x to the 4th minus 6x cubed. We're going to put together this positive 8x squared and -9x squared to get -x squared. We only have one x term. And we have minus 72. So we get a function f of x equals x to the 4th minus 6x cubed minus x squared plus 54x minus 72. Let's go over some more examples. So for example 2, we are given the zeros -2i and -1, and this is where our reminder is going to come in handy. So -2i is imaginary, or you can think of it as complex, which just means it has an imaginary and a real part. So if you see an I in one of your zeros, you have to know that those zeros always come in pairs. So what that means is if we have a zero of -2i, we're also going to have a positive 2i as our zero. So to find the other zero that comes with an imaginary zero, you want to flip the sign in front of the I term. So now we have our 3 zeros. So we have to write our factors first. So if a 0 is negative 2i, the factor that goes with that is x plus 2i. If a 0 is negative 1, the factor that goes with that is x plus 1. And if our 0 is positive 2i, the factor that goes with that is x minus 2i. So now to write our polynomial, we're going to multiply those together. I'm going to write x plus 1 first times x plus 2i times x minus 2i. And I would multiply these first because we're going to use a shortcut. It's going to save us a little bit of time. So we're going to keep this x plus 1 on the outside. And remember, when you're multiplying two sets of binomials that are pretty much the same, but one has a plus in the middle of the two terms and one has a minus, you really just want to square the first term. So you're going to do x squared. And then you want to subtract the second term squared. So subtract 2i squared. And if that doesn't make sense, you guys can actually FOIL this out and you'll get the same thing that I'm going to get. And now we're going to continue to simplify that right set of parentheses. So we have x squared minus 2i squared is 4i squared. And I'm going to put a reminder here that I squared is equal to negative 1. So that's going to help us continue to simplify this. So we have x plus 1 times x squared. So if I squared is negative 1, then negative 4i squared becomes positive 4, because negative 4 times negative 1 is positive 4. And now we're just going to FOIL out these two binomials. So we're going to do x times x squared, we get x cubed. X times 4 is plus 4x. 1 times x squared is plus x squared. And 1 times 4 is going to give us a positive 4. And let's just write this in standard form. So we're going to write it as x cubed plus x squared plus 4x plus 4. Let's go through two more examples, one that involves irrational roots and one that involves a little bit more challenging imaginary roots. So for example 3, we have the zeros 4 plus 2i and negative 2. So again, we have a complex root. So we have 4 plus 2i, so we know this comes in a pair. And the way to figure out the other root is you want to change the sign in front of the I part of your root. So our other 0 is 4 minus 2i. You don't change the sign of the real number. So we don't change the sign of the 4. So now let's write down what our factors are. So for our 0, that's 4 plus 2i. Our factor is going to be x minus 4 plus 2i. And let's just distribute that negative in. So we get x minus 4 minus 2i. For negative 2, we're going to have x plus 2. And for 4 minus 2i, we're going to have x minus 4 minus 2i. And again, let's just distribute this negative in. So we have x minus 4 plus 2i. So we're going to write our polynomial as the product of all of our factors. So I'm going to write x minus 4 minus 2i times x minus 4 plus 2i times x plus 2. And again, I'm going to use a shortcut to multiply out these two trinomials. So what we want to do is think of our trinomials as broken up like this. So let's do it in a different color. We're going to write it as x minus 4 and then minus 2i times, we'll do the same thing with the second trinomial. So x minus 4, but this time it's plus 2i. And we're going to use the same strategy that we used on the last problem with x plus 2. So now we pretty much have these two, you could think of them kind of like binomials where the first term is x minus 4 and the second term is plus or minus 2i. So we're going to use that shortcut where we can square the first part. So it's going to be x minus 4 squared. And then you can subtract the second part squared. So subtract 2i squared. And again, if you actually FOIL this all out, you'll get the same thing. The middle terms are going to cancel out because we have a minus in between one of our parentheses and a plus in the other. And I should have put some brackets around this. And we have x plus 2 still. So now we're going to go through and simplify this. So remember that x minus 4 squared is like x minus 4 times itself. So I'm going to write it like that. And then minus 2i squared is going to be minus 4i squared times x plus 2. And now we're going to have to FOIL out this x minus 4 times x minus 4. And for the sake of time and space, I'm just going to skip the middle step. So if you actually FOIL it out, you should get x squared minus 8x plus 16. And then minus 4i squared turns into positive 4 because remember I squared is negative 1. And then we have times x plus 2. Bring this up here to finish simplifying. I'm going to combine like terms in that first set of brackets. So it's going to be x squared minus 8x plus 20 times x plus 2. I'm going to rewrite it with the x plus 2 in front. X plus 2 times x squared minus 8x plus 20. And now we want to distribute the x and the positive 2 into the second set of parentheses. So x times x squared is going to give us x cubed. X times negative 8x is negative 8x squared. And x times 20 is positive 20x. 2 times x squared is plus 2x squared. 2 times negative 8x is negative 16x. 2 times 20 is positive 40. And finally, let's just combine like terms. We only have one x cubed term. We have negative 8x squared and positive 2x squared. That's going to give us a negative 6x squared. Positive 20x minus 16x is positive 4x. And we have plus 40. So we get our polynomial as f of x equals x cubed minus 6x squared plus 4x plus 40. Let's go through one more example that involves irrational roots. So for our last example, we are given the zeros 5 and 1 minus the square root of 2. So just like complex roots, irrational roots are also going to come in pairs. So if 1 minus the square root of 2 is a root, 1 plus the square root of 2 is also going to be a root. So you change the sign in front of the root. So now we're going to write our factors. So if a 0 is 5, then the factor is x minus 5. If a 0 is 1 minus the square root of 2, the factor is x minus 1 minus the square root of 2. Let's distribute that minus in to get x minus 1 plus root 2. And if our root is 1 plus the square root of 2, we're going to get a factor of x minus 1 plus root 2. Distribute that negative in to get a factor of x minus 1 minus root 2. So then to write our polynomial, we're going to multiply all our factors together. So I'm going to write it as x minus 1, plus the square root of 2 times x minus 1 minus the square root of 2 times x minus 5. And we're going to do that shortcut again and multiply these first two trinomials. So we're going to think of this first set of parentheses as x minus 1 plus the square root of 2. And then the second one we're going to think of as x minus 1 minus the square root of 2. And then we still have this x minus 5. And now we're going to use our foiling shortcut where we're going to square the first terms and subtract the second term squared from it. So we're going to square x minus 1. So we're going to do x minus 1 squared minus the square root of 2 squared. Put this in brackets because this entire thing is going to be multiplied by x minus 5. Remember, x minus 1 squared is like x minus 1 times itself. And when you square a square root, they cancel out. So the square root of 2 squared is just 2. So we get minus 2. And we still have times x minus 5. If we multiply out x minus 1 times x minus 1, you should get x squared minus 2x plus 1. We have this minus 2 times x minus 5. And we'll simplify what's in the brackets. So we'll get x squared minus 2x minus 1 times x minus 5. And then finally over here on the right, we are going to multiply these out. So I'm going to rewrite it as x minus 5 times x squared minus 2x minus 1. I'm going to distribute this x into the second set of parentheses. So x times x squared gives me x cubed. X times negative 2x is negative 2x squared. X times negative 1 is negative x. Now we want to distribute the negative 5. Negative 5 times x squared is negative 5x squared. Negative 5 times negative 2x is positive 10x. And negative 5 times negative 1 is positive 5. Finally, we just need to combine like terms. So we have x cubed. Negative 2x squared minus 5x squared is negative 7x squared. Negative x plus 10x is positive 9x. And we have this plus 5. So we get f of x is equal to x cubed minus 7x squared plus 9x plus 5. So hopefully this video helped you guys understand how to write polynomial functions given the zeros or the roots. If you want some more practice with problems similar to the ones we worked through today, check out the link in our description for a free practice worksheet.